Welcome to the SPE podcast, powered by the Society of Petroleum Engineers. You're listening to SPE Live, permanent magnet motors and artificial lift, technologies, safety, and best practices from the Permian to the world. The audio from this episode was previously recorded on April 30th, 2025.
Hi everyone, welcome to SPE Live on permanent magnet motors and artificial lift. Technologies, safety, and best practices from the Permian to the world. I'm Shivani Vyas. I'm sales manager at Odessa Separator, and I'm going to be your moderator today. Today's SPE Live is 30 minutes, so we do encourage y'all to go ahead and ask y'all's question on the chat while the session is going on. And now it's my pleasure to introduce our guests. Dakai Yin is an industry-recognized expert in electrical submersible pump technology with over 20 years experience. After earning her Master's of Science degree in Civil Engineering from Tsinghua University, Dakai entered the oil and gas industry. Dakai joined Oxy in 2014 as the ESP engineer supporting Oxy's offshore operations in Qatar. As a senior subject matter expert, SME, in Oxy's production operations technical support team, her goals include new technology evaluation and trial, vendor qualification and management, and root cause analysis, failure analysis. In addition to her primary job function, Dakai is also involved in SPE, career fair events, and the program committee for SPE Gulf Coast Section's ESP Symposium. We'll also welcome our second guest, Lauren Simmons, joined Lavar, previously Boritz, in 2016 as the Vice President of Marketing and Sales and serving later as Chief Marketing Officer. Before joining Lavar, Lauren spent nearly 27 years with SLB, where he started his career in oil and gas as a wireline field engineer working throughout Western Canada and Alaska. Lauren moved into the artificial lift and completions world over the second half of his tenure at Scalable, serving in management positions both domestically and internationally in product development, operations, and marketing. Lauren currently serves as the North American Director of Quality and Training and holds a Bachelor of Science degree in Geophysics from the University of British Columbia. Dakai and Lauren, welcome to this SPE Live. Y'all are seen as the experts in the industry, especially ESP, and we're really glad to have y'all on this ESP Live.
Thank you.
Thank you, and good morning.
Well, now we do know that PMMs have been the buzzword lately, but let's go ahead and start. When exactly or how long has the PMMs been in the industry?
Thanks, Shivani. Well, the easy answer to that is probably a lot longer than most people think. Of course, unless you are an early adopter and you're already using PMMs. But in fact, I can only speak to the specifics of my own company. But the major R&D effort around PMMs actually started back in the mid-1990s in Russia. The company commercialized the first PMM going back to 2006. So it's been around quite a while. In that period since, from about 2010 onward, a lot of expansion in motor sizes, horsepowers, that type of thing, as well as development. A lot of development was concentrated on the control algorithms and the surface drives as well. So right now there's a wide portfolio of horsepowers, model sizes available. And as I think some of the probably people in the audience and the other providers can speak to, it's expanding the adoption as we go forward.
Thank you, Lauren. Dakai, anything that you want to add on to that as far as just the industry side and operators' perspective?
Yeah, from the operator side, like Lonnie mentioned, we noticed the PMM application for a while, right? Especially in the Russian market. I think they're the first to use them, very populated in West Siberia. Was interesting as actually back in 2019, our company actually did we call it tour of PMM because we tried to look into this technology. So we even went to that country, toured a lot of manufacturers, tried to see what's the reliability, where's the technology maturity. of the PMM technology. But I would say, like Lonnie mentioned, it's a long history, but the recent booming of the PMMs in the last 5 to 10 years.
Got it. Thank you for that. And now let's go ahead and understand the difference between, obviously, folks might maybe understanding the IM's way better, but if we can deep a little bit, deep onto the difference between the PMM and the IM, that would be great to start off with.
Sure. Well, let's take a look at the physical construction first. That's the best place to start. And I think you can see the slide. The graphic depiction you see there is a depiction of the induction motor, and on the right, the permanent magnet motor. If we consider that the stator on both is by and large the same in that it takes three-phase AC power, generates a rotating magnetic field, it's really in the rotor construction where the main difference lie. So if you consider on the left the induction motor, the rotor in the induction motor is constructed with copper bars that get shorted at either end. And it's in that copper squirrel cage, if you will, hence it gets its name, is where current gets induced in the rotor copper bars. And the induction of current then creates a secondary magnetic field or a rotating magnetic field, a static magnetic field in the rotor. And it's that magnetic field of the rotor that interacts with the stator magnetic field. In contrast, the permanent magnet motor has permanent magnets already installed in the rotor construction. And so the presence of the permanent magnets is what creates that rotor magnetic field. And it's that magnetic field that then interacts with the rotating magnetic field of the stator. So the main difference there is that by eliminating the copper bar construction, you eliminate the induced current and therefore eliminate the power that's consumed by inducing that current, as well as the heat generated in the rotor.
Got it. And would you say there's advantages, and Kai, feel free to jump in on this as well, advantages on using PMMs versus the IM?
Well, absolutely. By understanding that the differences in construction, things like motor efficiency, PMMs will enjoy typically a 10 to 15% benefit over the equivalent horsepower IM motor in motor efficiency. Power factor is a big one as well. So the power factor is near constant across the full load and roughly 10 to 15% higher than the equivalent induction motor. Operating current, big benefit there. So it operates at a lower current for the reasons you can see that the physical construction reasons pertaining to that. Just the weight and size, because you've got this higher horsepower density in the rotor, you actually decrease the size of an equivalent horsepower motor PM to IM roughly about 40%. And then, of course, that all adds up to the big one, right? And that's the cost reduction in power consumption and therefore the electrical cost savings.
Yeah, like last week I was at the Southwest. I saw a very interesting paper proposed by Mike Romer from the operator side. They did a very detailed comparison between PM and IM motor in unconventional and basing area. There was an interesting statement. They did compare with unconventional and conventional. They see across the board stable savings on the powers. I think that's one of the major reasons, even though this technology has been there over 20 years, but the reason it's booming is because our industry is also looking for, less footprint, more power efficiency. That's make the PMM come into the picture in the last 5 years.
Yeah, definitely. I can definitely relate to that, especially in the Permian Basin where, some of the counties, we still struggle having that power line and trying to go ahead and run our ESP. So that's a big one right there. What about obviously when we talk about PMMs, there are some HSE factors that we have to go ahead and take into consideration. And that's a big one where, I believe it's taken such a long time for the industry to adapt as well as have it on such a regular basis. What are some of the risks that would be associated with PMMs as far as HSE goes?
Well, absolutely. If you think back to that construction again, you've got permanent magnets that rotate in copper coils, right? And so when there's no power applied, if the shaft of a PMM rotates the rotor inside that stator. It acts like an AC generator. And so as a consequence, any unplanned shaft rotation can produce voltage and current, and therefore the risk being electric shock at the motor or cable end on the end of it. So that's the big one. Electric shock or arc flash really is what needs to be managed. That's the main risk.
From the operator side for us, as Lonnie mentioned, the bad part of electricity is nobody can visually see it, right? So main concern from operator during the ESP operation, not only about when you install it or pull it, also is exposures for your field personnel.
Sure.
So like for our pumpers, contractors, whoever, or even like livestock, right? Whoever can expose to the well side, and that's for us to take proper measurement from engineering standpoint or training, education, try to eliminate the risk factors of that part.
No, definitely makes sense. And I will jump back to it in details if we have enough time on all of that HSE factors. But I was really curious, when we talk about ESPs, we cannot not talk about gas conditions, right? What do the ESPs operate better? Is it worse whenever there's gassy situations with PMM? Kyle, start with you. I know you're smiling right there.
I'll jump in that. Gassy well, right? So gassy well, I guess different people have a different definition about the gassy wells. And we're focused on permitting today. I guess for permitting, the gassy well, usually we see two situations. One is on unconventional wells. Typically, we see when your intake pressure below 600 PSI, if your gas liquid ratio above 1,000, for ESP, we treat it as a gassy wells because you do start have a gas interface with your pump. But it also depends on how good your separations, right? And that could make a big difference on ESP operation. When we're really struggling for unconventional is when your gas liquid ratio is about 1,500 or your gas starts slugging really bad. So when that happens, what we notice if we apply PMM motor, we do see the motor run a little bit cooler than IM motor. I would say average 5 to 10 F degrees cooler. And that will help you to reduce or delay or the motor temperature trip, which means you avoid multiple ESP shutdowns. Another thing we notice is because of the feature of the PMM, you do have much lower idle amps. From my experience, typically the PMM idle amps is in single digit, means your idle amps are like 5, 10 amps, versus a PMM motor, your idle amp could be as high as half of your motor amps, right? So that's giving me more room to control from the underload set point. My underload set point could be much more useful. That's one can help the pump to process the gas, also delay the multiple shutdowns. Another thing for PMM we notice, because it's synchronized much better than IM motor, even you're running like similar frequency. By similar, I mean if the 60 hertz versus 120 hertz in PMM, your motor speed is a little bit faster. That helps your pump to handle the gas better. So those are the changes we'll notice. But for my self-experience, gassy well conditions heavily rely on how the pump can handle the gas versus on the motor end. But we do see the advantage, like Lonnie mentioned earlier, PMM motor on the market, they have smaller OD motor you can choose from, which can help you increase the clearance, increase your gas separation, or because of power density, you have to have shorter ESP strings, which means I can set my ESP pump a little bit deeper. I merge the pump deeper, even though for the same fluid level, I can have less gas problems. Another thing is for unconventional wells, when the PMM motor, they have a higher power factor across the motor load, which means in the unconventional wells, even you have a gas interface, but at a certain point, the power consumption difference will be big enough for me to introduce smaller VSD at the surface to release a big VSD earlier to use a big VSD for the other newly drilled wells. So that's from the gas handling point we see what's the advantage of PMM.
Thank you. Lauren, anything that you would want to, I think she pretty much covered it.
I think she covered it all.
As far as installations and PMMs, how many, let's start with the Permian Basin first. How many installations, Lauren, you think from, y'all side, server side we have, as well as the Kai you can speak about Oxy, and how many are currently operating?
Yeah, well, I can go ahead and tell you that as far as since we introduced PMMs, we're up near around 2,000 installations now over that's it since about 2013. But as Dekai's alluded to, the real ramp up has come in the last 5 years.
Yeah, I did a little bit of research before our session. I think from, of course, different resources, the number may or may not be very accurate. I think based on the different input, I'm expecting currently in Permian Basin, we probably have about 700 live PMMs at this moment. Okay. And if you count for the history or the last 5 to 10 years, I think total installation in Permian, I would think anywhere between 2,000 to 2,500. And if you especially look at the last 3 years since 2021, the installation every year, I think, is doubled. We're on the very fast ramp up in the last 3 years. Of course, this have to take time on people accept the technology, the learning curves. We have to give training and education resource. Also, like this kind of event from SPE or from different professional forum to boosting the technology. And also, saving recognitions. That's take time, right? So even you install PMM a couple of years, but based on the data you collected, by the time people realize, okay, this is the advantage or the savings for this technology. And also, I think 2023, we finally have an API standard about PMM safety 11S2. That also helps people to willing to accept or apply this technology.
No, absolutely. And, we did talk about some of the HSE challenges, but what about the implemental challenges that y'all have seen recently? Let's talk about where it was initially versus what it is now.
Okay. I think initially, as a new technology, people is always scared of what you don't know, right? So the new technology always have a risk factor for people to understand or willing to use it. And that's very critical from production side. What's a mindset from engineering, from facility, from even electric team, HSE team, how well they're willing to accept this technology. Of course, over the years, by deal with that challenge, we increase our safety requirement. A lot of training modules developed for different role of the operations. There's different even equipment developed, like when you install them, they have this special equipment that can monitor live motor current, try to detect the backspins. Like Oxy at the company, we even for each PMM job, we have special GSA meetings just to make sure all the party aware, okay, this is a special installation on PMM. Everybody should aware what should do or what should not do. And another thing, technical wise, on surface equipment adaptability. In Permian, before we have a lot of water flood well. For those wells, typically they have a switchboard. Are they willing to change that to drive? And plus, is that drive could be compatible between IM and a PMM motor, or do you need to upgrade those drives? Those are all the technical challenges. And also not forget about the cost, right? Even though these days, the PMM motor cost itself is fairly close or equivalent to IM motor, but there are other costs associated with it, like accessories you need during the pull and the run, right? Training is the actual cost. It's actual safety measures or signage or use. And another cost in the future could be what's the reusability of PMM motor, because we don't have a long enough history to build up versus IM motor. So people still questioning how many times I can reuse it. Is the magnetic is going to de-energize, or how I'm going to confirm the motor when it's pull out, what's the reusability. So those are some of the challenges we have been facing or we try to solve in the last few years.
Got it. No, that's definitely very insightful. And that gets me to my next question. So, these are the challenges we have gone ahead and trying to go ahead and resolve it. How do we go ahead and manage the future better? So next question, pretty simple, is what is the future of PMMs? Where do you all see it?
For the future, I think I'm a strong believer on PMM technology, right? I think it's got very wide acceptance by our industry and even outside artificial lift, right? I do see Oxy, we have some CO2 capture project, and there's some big wells, of course, for those type of projects we require clean energy, right? So which means all the energy we have to use be super high power efficient. So I also think PMM could be the future there. And also not only in ESP, right? Oxy start trying PMM on rod pump surface motors. We tried the linear ESP in downhole rod lift. We're still also trying PCP PMMs. There's some 16 post motor, which that's another advantage of PMM. You can run it really slow, right? Of course, in ESP world, everything wants to run it fast, but there's some of the applications they want to run it slow. So PMM can help you. The 16 post motor, they can run extremely slow. So in the other lift type, we can use them too. So I think I also saw some interesting report on the industry showing, currently in U.S. land, about 15 to 17% of the downhole motor is PMM. It's quickly that number could be over 20 or even 30. So in the future, could be very likely 1/3 of the application on ESP could be PMM. Another technology that has been really interesting in the last few years is ultra high speed ESPs, right? So which means the ESP around 10,000 RPMs, right? There's a very advantage for unconventional wells. If you're looking for one lift type in the well life cycle, I think the ultra high speed ESP could be the solution, especially for gas handling. So that's, I think, a future for PMM too. So I think PMM have a bright features. I just need a time for people to accept them. And I do see a good path we're going to heading that way. I think, Lonnie, you probably have more insight from the engineering design.
You once again touched on a great number of subjects, and hard to add more, but I will. I agree with you. I think the future is very bright. I do think that we'll see sort of a continued expansion of both the application, some niche applications too, where it may require sort of either new materials, different horsepowers and different geometric packages. So obviously everyone's trying to go smaller, but still have the sufficient horsepower. So I think that will kind of be an envelope that keeps getting pushed. But the other thing too that I see happening too, in order to, let's say, improve that and assist with that, and also deliver the reliability improvements, maybe in the manufacturing techniques. We don't often talk about that so much, but I think that's where, particularly as Dekai alluded to, outside industries already exploiting that in a lot of other industries now. And so as that perhaps morphs into our business, we can exploit the better beneficial manufacturing techniques as well. I also think one more thing to that too is going to be a continuation of the development of the drive technology. How we control these things better and better. And as we understand it, I don't want to throw it all on the same heap, but obviously the artificial intelligence and predictive analytics and all that will as it is now, it's coming in. So it's simply going to benefit the use of PMMs as well, I would say.
Yeah, no, I would agree with both of y'all. Thank you for that insight. I know we have a lot of questions coming in the chat, so I think it's good to go ahead and start with the questions. I'm going to go ahead and do the first one. It's from Orlando Campos. Based on the construction of the VSDs, what do you think is better for PMM motors? 6 pulses, 12 pulses? There is no difference?
I can chip in a little bit because in our operation in Permian, we use both 6-pulse and 12-pulse drives. The difference is mainly on the input side because you have about better power feedback. But based on our experience on the output side of the drive, as far as go to the PM application, I don't think it's made a huge difference from my experience. So I would say from that side, I don't see a huge difference. On that side, on PM and IM motor is mainly what's a control method from the drive, which that could be a different control method, but that doesn't matter if you're 6-pulse or 12-pulse.
Yeah, I would agree.
Thank you. Second question is from Ken Savith. According to the experts, are the developed ISO documents surrounding the PMM safety being largely utilized by operators, or is it still being adopted?
So I'll lead with that one, Dekai. I think what Ken means is the API 11S9 effort, right? Because that was a catalyst, obviously, to wider adoption. We had great industry participation, both from the vendor side and certainly the operator side. And I think as a sort of a watershed exercise, it got a lot of issues on the table, a lot of great debate. And I know Oxy was front and center in that effort as well. So yes, I think it has made a big difference in the adoption because it's got sort of somewhat standardized approach to managing these risks included and all that. We use it now. It's central. We were obviously a contributor to that like so many others, but our own internal procedures and documentation reflect that API document as well.
Thank you. Next one is from Martin Lozano. How does having a smaller motor help you with the gas separation?
I think I didn't quite understand the question. It's not as necessary you have to use a smaller motor, but like when you have a gas handling, your motor load changes dramatically, right? For example, if a 100 horsepower motor, when you pump is producing all liquid, the pump may be demanding 80 horsepower. But when you're handling gas, because the load is much lighter, your motor load will be reduced. Not necessarily mean you have to install a smaller motor. But when the motor load changes, the big difference is the PMM motors still have high power factors, which means you're still efficient. Another thing is the PMM motor idle amps a little bit down, like only 10, 20%. So you have much more room to better control the motor. I don't know, did I answer that question?
If I can add to that, Dekai, that last point, because it is sort of crucial in the gas environment, right? So because that idle lamp is so much lower, what it means is compared to an IM, you have better resolution when you're running underloaded. So you can actually detect those events and not, so let's say, mistake them for an idle situation. But what that permits you is in your drive settings and your underload set points, you have better visibility and better resolution to tighten that up and control performance in an underload, possibly gassy setting, right?
Yeah.
Next one is from Todd. Says, I was involved with evaluating PMMs in late 80s. By the early 90s, we were limited by maximum temperature. What is the maximum temperature for application of these new motors?
The motor winding it's 200 degrees Celsius. It's rated for today. So we typically run, I think, to run around 285. That type of temperature. So it's there's no difference actually. I mean, it's better because it runs a little lower, but the motors are rated for 200C.
Okay.
I think originally the temperature concern was about the magnetic demagnetization, but now most of the industry is using much stable magnetic materials. I think that technical bottleneck has been solved.
Yeah, that's a good point, Dekai. I mean, as far as temperature rating on the magnets, I didn't mention that, obviously, just to be brief, but the samarium cobalt's been our magnetic or permanent magnet of choice. And it has such a high curry point. And given the experience and the longevity of some of the runs we've seen, we've not ever experienced any kind of situation of demagnetized magnets.
Thank you. I'm going to take the last question, and it says, can PMMs, from John Benton, can PMMs generate high starting torque?
Well, yes, but that's going to be a function of the number of poles. You know, in talking about the construction and very briefly, PMM motors can be constructed with multiple poles. We use 4-pole motors, but in our PCP applications, we'll use a 10-pole motor, and that's specifically designed for higher torque applications.
Got it. Thank you. Well, it's almost time to wrap up. I really wanted to thank again our guest speakers, Dakai and Lauren. Thank you for the insightful conversation. All the members who've joined us, the audience, thank you for participating, listening to our conversation and the questions. We really appreciate your participation, and we'll go ahead and see you on the next one. Thank y'all.
Thank you, everyone. Thank you, Shawnee and Lauren.
Thank you.
Thanks for listening to the SPE Live podcast. For more content, visit the SPE Energy Stream, the industry's digital pulse, at streaming.spe.org. If you enjoyed today's show, don't forget to subscribe and review. Join us next time on the SPE Live podcast.